Welcome to the deep dive. It's really great to have you with us today.
Yeah, glad to be here.
Now, if you're someone who keeps even a casual eye on robotics or artificial intelligence or, just the general future of technology, I'm willing to bet your newsfeed has been completely chaotic
Oh,
lately.
absolutely chaotic.
You log on and suddenly you're seeing all these seemingly disconnected, massive headlines. One minute you're reading about this permit for a massive supercomputer expansion in Memphis. The next, it's about these metallic gold robotaxis being spotted down in Texas.
Right.
And then, out of nowhere, there are reports about a million-satellite data center constellation being deployed in orbit. It just feels like total information overload.
It really does.
And it's incredibly easy to look at all of this and just see a fragmented jumble of unrelated tech projects.
Well, it really does look like chaos from the outside, doesn't it? I mean, when you have advancements happening simultaneously in automotive manufacturing and aerospace engineering, artificial intelligence, telecommunications, the human brain naturally tends to compartmentalize them. We put the car stuff in one box, the space stuff in another box, and the AI stuff in a third.
Sort of isolate them to make sense of it.
Exactly. But if you step back and look at the underlying architecture connecting all these recent developments, that compartmentalization is actually a complete illusion.
And that brings us to our mission for today's deep dive. We're going to map out what institutional analysts are now officially calling the Muskonomy.
And Muskonomy, yeah.
We've gathered a massive stack of sources from early 2026 to figure out exactly what's going on beneath the surface of all these crazy headlines.
And it's a deep stack.
It really is. We're looking at dense, official FCC filings,
Yeah.
the transcripts from Tesla's Q4 2025 earnings call, a really fascinating white paper titled The Integrated Singularity.
That one is key.
Definitely. We've also got an in-depth conversation from the World Economic Forum in Davos, and even this completely surreal surprise X-Space conversation that happened on New Year's Day.
Yeah, that space was wild.
We're taking all of this to reveal the hidden architecture of Elon Musk's interconnected empire.
And to give you a roadmap for where we're heading in this conversation, we need to fundamentally stop looking at these companies as separate corporate entities.
Right.
The most accurate way to understand this ecosystem, at least based on the literature we're analyzing, is to think of them as a single, vertically integrated biological organism.
Okay, I like that framing.
In this model, XAI acts as the brain, right, the core reasoning engine. Tesla represents the physical body, giving that intelligence hands and wheels to actually interact with the physical world.
Got it.
Then SpaceX and Starlink are the nervous system and the logistical supply chain, moving data and mass across the globe and into orbit.
And the final piece.
And finally, X-Money is the financial glue. It's essentially the cardiovascular system circulating value and capital throughout this entire ecosystem.
That biological metaphor is exactly how we're going to structure this discussion. And for you listening, understanding how these pieces fit together is essentially your shortcut to being well-informed about the next decade of technological disruption.
Highly recommend paying attention, yeah.
Because this isn't just about cool new gadgets or the latest smartphone feature. We're talking about a fundamental structural shift in how human labor, energy generation, and intelligence will operate on this planet.
And, as we'll get into later, potentially off it.
Exactly. Off it as well.
It's a shift from a legacy economy based on human physical labor and terrestrial fossil fuels to an entirely new paradigm. One based on automated labor, physically embodied artificial intelligence, and extraterrestrial energy capture.
It's the kind of massive paradigm shift we only see maybe once every few centuries.
Literally centuries.
Okay, let's unpack this, starting with the brain and the body. We have to talk about the absolute bombshells that were dropped during Tesla's Q4 earnings call.
Yeah, that call was a turning point.
For years, if you asked anyone what Tesla's mission statement was, they would tell you, almost by rote, to accelerate the world's transition to sustainable energy.
Right, lithium-ion batteries, solar panels, replacing the internal combustion engine.
Exactly. It was all about cars and solar. But on this specific Q4 call, Elon Musk announced a formal structural update to the company's mission statement. The primary focus is now on generating amazing abundance.
Amazing abundance.
And how do they define this abundance? Through a future marked by universal high income, generated primarily by humanoid robots, driving down the cost of physical goods and services to near zero.
It's a massive pivot.
Tesla is pivoting hard from an automotive manufacturer to becoming an embodied AI company.
The sheer ruthlessness of that pivot is what really stands out in the earnings transcript. I mean, when a legacy hardware company changes its mission statement, it's usually just marketing fluff meant for a slide deck.
Yeah, just rebranding.
But Tesla immediately backed this up with drastic, painful operational changes. The biggest shockwave was the announcement that they are officially discontinuing the Model S and the Model X.
Right, and we shouldn't gloss over what a massive deal that is. The Model S is the flagship vehicle that literally put Tesla on the map.
It changed the whole industry.
It's the car that broke the stereotype, that electric vehicles were just glorified, slow golf carts. It defined their brand for over a decade.
Exactly. And they are shutting down production of those legacy flagship models for a very specific reason: to free up factory floor space in Fremont, California.
And not for a new luxury sedan.
No, not at all. They are ripping out automotive assembly lines to build dedicated robot assembly lines for the Optimus Gen 3 humanoid robot. The physical footprint of the factory is literally transitioning from car production to synthetic human production.
It's the end of an era for the automotive side of things, but the beginning of something entirely unprecedented. And the car side of the business that is remaining is transforming just as radically.
Oh, absolutely.
Let's look at what's happening down at Gigafactory Texas. According to the Q4 notes, they are aggressively ramping up test manufacturing for the Cybercab ahead of mass production in April.
And we actually have visual confirmation of this now.
We do. Drone footage from an independent tracker named Joe Tegmeyer captured 25 of these Cybercabs out on the test track in a single day. And we really need to paint a picture of these vehicles for you.
They look like something out of Blade Runner.
They are painted this striking metallic gold. They have these sleek, aggressive, autonomous-only designs, and the most critical part of the engineering. There are absolutely no steering wheels.
None.
No acceleration pedals, no brake pedals. If you get into a Cybercab, you aren't a driver anymore. You're simply cargo.
Which completely shifts the liability and the entire design philosophy of the vehicle. But what's equally revolutionary is how they are building these Cybercabs.
The Unboxed method.
Yes. The earnings call detailed a complete departure from traditional automotive manufacturing, utilizing what they call the unboxed manufacturing method. To understand why this is a big deal, you have to look at how cars have been built for the last century.
Right, the Henry Ford model.
Exactly. Ever since Henry Ford pioneered the moving assembly line, cars have been built linearly. You start with the chassis, it slowly moves down a track, and workers or robots add parts sequentially. Doors, engine, seats, steering column.
One piece at a time.
That linear process requires a massive, sprawling factory footprint and takes a considerable amount of time because a delay at Station 4 backs up the entire line.
Right, it's a massive bottleneck.
Yeah.
But the unboxed process completely throws that linear model out the window. From what I understand in the technical breakdown, instead of a single line, you build major modules of the Cybercab completely independently.
In parallel.
Yeah. So you have one team or robot cluster building the entire front assembly, another building the rear casting, another building the floor and structural battery pack, all simultaneously in separate parallel zones.
And they even paint these modules before they are ever assembled together.
That's right. And then, only at the very end of the process, these massive, fully completed sub-assemblies are brought together in a final integration step, snapping together almost like Lego bricks.
The manufacturing efficiency gains here are profound. It allows them to shrink the factory footprint significantly because you don't need a mile-long line. But more importantly, it dramatically increases production speed.
And the target speed is just crazy.
The target they stated on the call is staggering. They are aiming for a production speed of one Cybercab rolling off the line every 10 seconds.
I really had to run the math on that when I read it. One car every 10 seconds. That means from a single facility, if running continuously, you're outputting over 8,000 vehicles a day.
It's hard to even conceptualize that volume.
That completely breaks traditional supply chain models. It's an insane volume.
It is, and frankly, we have to look at the supply chain bottlenecks that come with that. Producing 8,000 advanced autonomous vehicles a day requires an unprecedented flow of raw materials.
Lithium, rare earths.
Exactly. Lithium, rare earth metals for the motors, semiconductor chips. Tolerance stacking also becomes a nightmare.
What do you mean by tolerance stacking?
Well, if the front module is off by a millimeter and the floor module is off by a millimeter, when you try to snap them together at the final integration stage, the whole car fails. Tesla is betting that their precision casting and automated assembly can overcome those traditional manufacturing hurdles.
But let's say they pull it off. Let's say they hit that 10-second mark. That creates a secondary, much more complex challenge. because having millions of steering wheelless robotaxis and bipedal Optimus robots wandering around our cities and factories is totally useless.
And frankly, incredibly dangerous.
Yes, incredibly dangerous if they don't share a unified, highly advanced brain. You can't just have 3 million independent dumb robots trying to navigate downtown Manhattan.
No, it would be pure chaos.
And that brings us to XAI and the Grok neural network. During the earnings call, it was explicitly stated that Grok is no longer just that slightly sarcastic chatbot you interact with on the X platform.
The architecture has evolved.
It has. Grok is now being designed explicitly as the Orchestra conductor.
Orchestra Conductor is the perfect terminology for the architectural role Grok is playing. If you have a fleet of millions of autonomous cars and humanoid robots, they cannot operate as isolated agents. They require a centralized reasoning layer to manage complex, macro-level orchestration.
Like air traffic control, but for the ground.
Precisely. Think about the logistics of a robotaxi fleet in a dense urban environment. Grok isn't just telling the car how to avoid a pedestrian. The localized FSD chip does that.
The micro decision.
Right. Grok is managing the fleet-level pickup and drop-off logistics, predicting traffic flows based on real-time city data, and dynamically routing vehicles to areas of high demand before the demand even spikes.
Wow.
Similarly, on a factory floor, Grok manages the task-switching behavior of Optimus robots, coordinating their movements so they don't collide while moving heavy materials.
But to train an AI to be a competent orchestra conductor for the physical world, you need data. And not just text data scraped from the internet, which is what early language models relied on. You need physical, spatial, real-world data.
The hardest kind of data to get.
Exactly. And this is where we get into the concept of the data advantage. You see analysts in our sources constantly talking about Tesla's temporal moat.
Temporal moat, yes.
What's fascinating here is how this moat actually functions. Let's break down the mechanics of that, because it's not just a buzzword.
It's the foundational concept of their entire valuation model. In technology economics, a moat is your defensible competitive advantage. A temporal moat means your advantage is strictly based on time and the speed of your iteration cycles. You can't buy a temporal moat, you have to live it.
You have to put the time in.
Exactly. Tesla currently has a fleet of over 9 million hardware-equipped vehicles on the road globally. Those vehicles collectively have driven over 8 billion miles using the full self-driving software.
And every single second those cars are driving, their cameras are recording.
Every single second. Every day, those 9 million cars are capturing petabytes of high-definition, real-world video data. And they aren't just recording empty highways.
They're getting the weird stuff.
They are capturing edge cases. Bizarre intersections in Rome, sudden blizzards in Toronto, pedestrians carrying strangely shaped objects, construction zones with confusing signage. That sheer volume of diverse, multimodal data is something a competitor simply cannot replicate overnight, no matter how much money they have.
You can't just spend $1 billion and instantly have 8 billion miles of driving experience.
It takes years to accumulate that lived experience.
So all that raw video data, the good, the bad, and the weird, gets piped straight back to the brain. Specifically, it's routed to the Colossus supercomputer in Memphis, Tennessee.
Which is already massive.
Colossus is already one of the most powerful computing clusters on the planet, but according to the local Memphis business journals we pulled, XAI is not slowing down. They just filed a permit for a massive $659 million expansion at that exact site.
It's unbelievable.
They're building a colossal new 312,000 square foot facility right next to their existing Colossus 2 data center.
And the logistical footprint of a facility that size is staggering. You don't just plug a 300,000 square foot AI supercomputer into the wall.
No, you definitely don't.
The electrical draw is immense, and the thermal output, the heat generated by hundreds of thousands of AI chips, requires industrial-scale cooling.
Which is why the permit filings show they are actually building state-of-the-art water recycling plants on site. The Memphis aquifer is a crucial local resource, and running a massive data center traditionally requires millions of gallons of fresh water a day for the cooling towers.
It's a massive environmental strain.
They're having to build closed-loop recycling systems just to ensure they don't drain the local water table. And on the power side, Gwynne Shotwell, the president of SpaceX, who is surprisingly involved in this terrestrial project, pledged that they're developing 1.2 gigawatts of power specifically for this supercomputer stability.
To put 1.2 gigawatts into perspective for you, that is roughly the power output of a medium-sized nuclear reactor, dedicated entirely to training a single AI model.
Just for one computer brain.
Yes. They are building the physical infrastructure to process petabytes of real-world data at an unprecedented, almost frightening scale.
And the processing of that data leads to something truly revolutionary, which the Integrated Singularity White Paper calls the shared experience network effect. Because Grok acts as the central conductor for both the cars and the Optimus robots, the learning isn't isolated. It's distributed instantly across the entire fleet.
This is where it gets really sci-fi.
Let's use an analogy here. Imagine if you were trying to learn how to play a ridiculously complex piece of music on piano, like a Rachmaninoff concerto. You might practice for years to get the muscle memory right.
Years of repetition.
But imagine if you could instantly execute that concerto perfectly, simply because someone else, halfway across the world, practiced it, figured out the exact finger movements, and that knowledge was instantly uploaded to your brain.
The Matrix-style uploading.
Exactly. That is the exact mechanism happening right now with this robotic ecosystem.
It's a localized breakthrough resulting in a global upgrade. If a single Optimus robot in the Fremont factory struggles with grasping an irregularly shaped battery cell, runs a simulation, and figures out a more efficient kinematic movement to pick it up, that specific motor control breakthrough doesn't stay in Fremont.
It doesn't just benefit that one robot.
No. That telemetry data is sent back to Memphis, the central model's neural net weights are updated, and that newly learned physical skill is instantly beamed out to every single Optimus robot on the planet.
Incredible.
Similarly, if a Cybercab in Austin learns how to navigate a completely new type of erratic construction detour, the entire global fleet of 9 million cars now knows how to navigate that exact type of detour. The collective intelligence of the entire system upgrades simultaneously.
It creates this massive compound interest effect on physical capability. The robots don't age and forget. They only accumulate collective competence, which contextualizes why Elon Musk recently stated on the call that Tesla will likely be one of the companies to achieve AGI.
Artificial general intelligence.
Right, and almost certainly the thirst to manifest it in a humanoid atom-shaping form. Our sources point out that Demis Hassabis from Google DeepMind recently noted that AGI will have 10 times the economic impact of the Industrial Revolution, but it will happen at 10 times the speed.
10 times the speed.
When you combine xAI's centralized reasoning capabilities with Tesla's physical embodiment and that brutal, unboxed manufacturing scale, you can clearly see the architectural foundation for that claim.
The foundation is absolutely there. But, and this is a massive but, as our macroeconomic sources point out, there is a glaring, seemingly insurmountable roadblock standing in the way of this entire vision.
The energy issue.
Exactly.
Yeah.
Having the data and the factory capacity is meaningless if you hit hard physical limits on energy.
Which perfectly brings us to the core conflict of this deep dive. We have this massive brain in Colossus, we have these metallic bodies in Optimus and the Cybercab, but to make this global leap to artificial general intelligence, you need power. And I don't just mean a little bit of supplemental power. I mean terascale energy generation.
We are talking about fundamentally altering the grid.
Let's look at the incredibly revealing conversation between Elon Musk and Larry Fink, the CEO of BlackRock, at the 2026 World Economic Forum in Davos.
That Davos conversation is perhaps the most critical piece of source material we have for understanding the timeline of the next 5 years. You had Larry Fink, who effectively represents the consensus of traditional global capital, sitting across from Musk, who is laying out the harsh physical constraints of the future.
Reality check.
The prevailing narrative in Silicon Valley has been that compute is getting cheaper and more efficient. But Musk issued a very stark, counterintuitive warning to the global elite in that room. He said, and I quote, "We're very soon going to be producing more AI chips than we have the electricity to turn on."
That is a terrifying thought for the entire tech industry.
Mm-hmm.
We are rapidly building millions of these incredibly complex synthetic brains, but we simply don't have the electrical blood to keep them conscious.
Exactly. The limiting factor for the advancement of artificial intelligence is no longer algorithmic design. It's not the math. It's not even the semiconductor fabrication bottleneck at TSMC anymore.
It's just raw power.
It's the raw baseload electricity required to power these massive multi-gigawatt data centers, and equally importantly, the environmental resources required to cool them. We mentioned the water recycling plant in Memphis earlier.
Yeah.
That's a Band-Aid. The reality is that the projected global electricity demand for AGI training simply cannot be met with terrestrial solutions, whether that's natural gas, solar, or even current-gen nuclear, without placing immense unacceptable hardship on local communities, water tables, and national power grids.
You can't black out Chicago just so a neural net can learn to fold laundry faster.
You really can't.
This raises an important question. How do you scale AI to achieve this promised amazing abundance when the very act of scaling the compute infrastructure threatens to collapse the terrestrial power grid?
And that question, how to bypass the terrestrial energy bottleneck, is precisely what drove the most significant and initially confusing corporate restructuring of this decade. On February 2, 2026, SpaceX officially acquired xAI.
Here's where it gets really interesting because on the surface, this was a massive $1.25 trillion mega merger that left a lot of people totally baffled.
Well, Wall Street had no idea what to do with it.
You have a space exploration and rocket company buying a large language model artificial intelligence company. At first glance, analysts were scratching their heads. Why merge orbital launch vehicles with chatbots?
It didn't make sense.
But then, just days before the merger was publicly announced, SpaceX filed a highly detailed proposal with the Federal Communications Commission. They filed plans for a 1 million satellite orbital data center constellation.
Yes. The proposed solution to the terrestrial energy crisis is simply to physically move the AI compute infrastructure off the surface of the Earth and into low Earth orbit.
It sounds crazy.
It sounds entirely like science fiction, but when you break down the physics, the thermodynamics, and the economics of it, space is actually the ideal environment for a mega-scale data center.
I'm going to need you to break down those mechanics for us because when I first read orbital data center constellation, my mind just kind of short-circuited. We just established how hard it is to run a data center in Memphis. How is it easier to run one floating in the vacuum of space?
Okay, let's look at the two absolute biggest operational nightmares for any Earthbound data center. Acquiring uninterrupted electricity and getting rid of the massive amounts of heat generated by the processors. Space solves both of these problems naturally through its ambient environment.
Okay, so let's take power first.
First, let's look at power generation. Down here on Earth, solar power is intermittent. You have the day-night cycle, you have cloud cover, and you have atmospheric scattering that weakens the sunlight. But in space, specifically in sun-synchronous orbits between 500 and 2,000 kilometers up, satellites are exposed to direct sunlight more than 99% of the time.
Almost constant daylight.
Almost constant. Furthermore, because there is no atmosphere, no water vapor, and no weather to filter the light, the raw solar irradiance, the actual energy hitting the solar panels, is roughly 36% higher than it is on the surface of the Earth. So you have access to near-constant, unadulterated, highly potent solar energy.
Okay, so you have an effectively unlimited, highly efficient solar power source.
But that brings us to the second problem, thermodynamics. Down here, when a server farm pulls in massive amounts of electricity, it generates massive amounts of heat. We use billions of gallons of fresh water, huge chiller plants, massive HVAC systems to keep the silicon from melting.
It's a huge operation. How on Earth, I guess, how in space, do you cool a multi-gigawatt server farm in a vacuum where there's no air to blow across the heat sink?
You utilize a principle called passive radiative cooling. The ambient temperature of deep space, away from direct sunlight and Earth's albedo, is roughly minus 270 degrees Celsius.
Minus 270. That's barely above absolute zero.
Just slightly above absolute zero. Because there is no air in space, you can't use convective cooling like a fan. Instead, the heat generated by the AI processors is transferred to a large, dark-colored radiator panel that is continually pointed out toward deep space.
Just facing out into the dark.
Exactly. The heat energy simply radiates away from the panel as infrared light directly into the cosmic void. Based on the Stefan-Boltzmann law, a single square meter of radiator at room temperature can dissipate over 800 watts of heat into deep space.
So you don't need any water, you don't need massive industrial air conditioners. The vacuum of space literally acts as an infinite thermal sink.
Precisely. It entirely eliminates the ecological impact of water consumption and localized heat islands that terrestrial data centers create.
But wait, let's be critical here for a second. The physics of power and cooling make sense. But the sheer scale of what SpaceX is proposing in this FCC filing is staggering. They're asking for permission to deploy 1 million satellites.
It's a massive escalation.
To put that in perspective for you, the original Starlink constellation, which already dominates the night sky and caused huge uproars in the astronomical community, is roughly 9,000 satellites. They are talking about scaling that orbital footprint up by a factor of over 100.
Yeah.
What about Kessler syndrome? The idea that one collision creates a cascade of debris that renders orbit unusable. The FCC isn't just going to rubber stamp 1,500 kilogram satellites without a massive deorbit plan.
And that is the primary regulatory hurdle they face. The FCC filing specifically addresses orbital debris mitigation by relying heavily on the low altitude of the proposed deployment. These data centers would operate in very low Earth orbit, where atmospheric drag is still slightly present.
So they don't stay up forever if they die.
Right. If a satellite fails, it doesn't stay in orbit for centuries. Orbital decay brings it down to burn up in the atmosphere within a matter of months, not years. Furthermore, as we'll discuss when we get to the launch vehicles, SpaceX is developing active debris retrieval capabilities. But you're right, the regulatory battle over orbital crowding will be intense.
I can only imagine the hearings.
However, the economic math driving the proposal is what makes it so relentless.
The numbers in the filing are truly mind-bending. SpaceX project that if they can launch 1 million tons of these data center satellites annually, they could generate 100 gigawatts of AI compute in orbit. To contextualize that number, 100 gigawatts is equivalent to roughly 20% of the entire current electrical consumption of the United States.
That's a fifth of the U.S. grid in space.
And they want to dedicate all of that power exclusively to training and running the Grok neural network.
As Musk casually phrased it in a blog post defending the merger, space is called space for a reason. If humanity needs to build computational infrastructure that rivals the baseload power grid of a first world nation, we simply run out of viable real estate and ecological resources on Earth. You have to go up.
But going up presents its own massive, historically insurmountable logistical bottleneck.
Yeah.
You cannot launch 1 million tons of payload a year using traditional expendable rockets. The economics simply don't work. Even with the Falcon 9, you'd bankrupt the global economy trying to pay for the liquid oxygen, the methane, and the discarded rocket stages required for that many launches.
Which is the fundamental problem with the gravity well. Escaping Earth's gravity requires an immense amount of chemical energy. If you were trying to launch heavy infrastructure like massive solar cells, structural chassis, heavy radiator panels for millions of satellites, doing it from the surface of the Earth is highly inefficient, regardless of how cheap your rocket is.
And to understand how they plan to solve this gravity bottleneck, we have to look at one of those bizarre pieces of source material we analyzed. A completely unannounced surprise conversation on X Spaces that happened on January 1st, 2026.
Ah, yes. The New Year's Day conversation with Adrian Dittman.
Yes. So for context, Adrian Dittman is this user on X who sounds eerily, and I mean almost indistinguishably, identical to Elon Musk. For years, the community has half-joked that it's just Musk using an alt account, or maybe an incredibly advanced voice modulator.
It's a whole thing in the platform.
And on New Year's Day, Musk actually drops into a live space hosted by Dittman. They greet each other, completely deadpan as other me, and then they proceed to casually discuss the long-term roadmap for humanity's future in space. It's incredibly surreal to listen to. It sounds like two clones brainstorming.
It was very weird to parse.
But tucked inside this lighthearted banter was a wildly ambitious, specific plan for overcoming Earth's gravity well.
Musk outlined a strategy that bypasses the Earth launch bottleneck entirely. You don't launch the heavy infrastructure from Earth, you manufacture it on the moon.
It sounds straight out of a Robert Heinlein sci-fi novel. But he was dead serious. He said, and I'll quote the transcript here, "The biggest opportunity on the moon is to actually make solar cells and radiators. So you're manufacturing on the moon anything that weighs a lot. Chips can maybe still come from Earth because they weigh very little."
It's actually a very elegant solution.
And then he casually mentions how you get these massive solar panels off the moon and into orbit. You don't use chemical rockets, you use a mass driver.
This is where the physics get incredibly interesting. A mass driver is essentially an electromagnetic railgun.
A railgun on the moon.
Yes, because the moon has no atmosphere to cause aerodynamic friction, and it has only 1/6 of Earth's gravity, the escape velocity is remarkably low. You can build a long track on the lunar surface, use superconducting magnets to accelerate a payload container, and shoot it directly off the surface and into orbit without using a single drop of chemical propellant.
That's amazing.
You use raw electricity generated by solar on the moon to throw payloads into space.
In the audio, Dittman actually joked about pivoting from building Dyson spheres to building lunar railguns. But Musk responded with utter seriousness, stating that this lunar manufacturing process, combined with the mass driver, will be used to create a Dyson Swarm.
A Dyson Swarm.
For those unfamiliar, a Dyson Swarm is a theoretical megastructure consisting of a massive web of satellites orbiting a star, in this case the sun, harvesting its energy output. Musk stated they could scale this architecture to hundreds of terawatts of AI compute per year. We're literally talking about ascending the Kardashev scale of civilization development, moving from a planetary species to a stellar species.
If we connect this to the bigger picture, the entire feasibility of this lunar manufacturing hub, the mass drivers, and the orbital data centers relies entirely on two specific terrestrial technologies that SpaceX is maturing right now, today. Starship V3 and Starlink V3. Those are the physical supply chain and the nervous system that make this sci-fi vision possible.
Let's break the mechanics of those down. Let's start with the supply chain. Starship V3.
Starship V3 is the super heavy lift vehicle. SpaceX is targeting late 2026 for full rapid reusability. And rapid reusability doesn't mean landing a rocket in the ocean and towing it back over 2 weeks.
No.
It means launching this massive 400-foot tall rocket and then physically catching both the super heavy booster and the Starship upper stage directly out of the air using the giant Mechazilla chopstick arms at the launch tower. They catch it, set it back on the mount, refuel it, and launch it again within hours.
Just incredible turnaround times.
When fully operational, Starship V3 can carry 100 to 150 metric tons to orbit per launch. Musk has stated that achieving full reusability with this architecture could reduce the cost of space access by a factor of 100. It fundamentally turns spaceflight into a commercial airline operation. The hardware is a sunk cost, and you only pay for the fuel and the payload.
So Starship provides the muscle to get the silicon chips and the initial mining robots to the moon. But once those orbital data centers are operational, how do they actually talk to the Optimus robots back on Earth? That's where Starlink V3 comes in. Our sources from the 2026 Mobile World Congress in Barcelona outline just how incredibly powerful these new satellites are.
The first and second generations of Starlink provided decent, low-latency broadband. It was revolutionary for rural areas, but the bandwidth was limited. The V3 satellites are a completely different beast entirely.
A huge upgrade.
They weigh roughly 1,500 kilograms each, and they feature highly advanced optical laser crosslinks. Instead of bouncing radio signals down to ground stations and back up, the satellites communicate with each other using lasers in the vacuum of space, routing data globally at the speed of light.
Using lasers?
Yeah, they are capable of 1 terabit per second throughput. That is a massive 10-fold increase in data capacity over the previous generation.
So Starship provides the freight line, and the Starlink V3 optical lasers provide the ultra-high-speed, terabit-level data backhaul to connect the space-based Grok AI brains back down to the Optimus robots and Cybercabs operating in our physical world. It forms a complete closed-loop system.
The brain is connected to the body.
Exactly. And at that exact same Mobile World Congress, SpaceX announced Starlink Mobile, also known as direct-to-cell. They are bypassing traditional terrestrial cell towers entirely. They've partnered with major telecoms, Deutsche Telekom in Europe, T-Mobile in the US, KDDI in Japan, and they are beaming terrestrial-like 5G connectivity directly from orbit to unmodified standard cell phones in your pocket, no special dish required.
Which is the critical missing piece for the robotic fleet. It ensures that the Orchestra Conductor, Grok, never uses contact with its physical agents. Whether a Cybercab is in downtown Manhattan or an Optimus robot is in a remote lithium mine in Nevada, it has a persistent, high-bandwidth connection to the orbital brain.
Always online.
Always. But as with everything we've discussed, building super heavy rockets, developing lunar electromagnetic railguns, and manufacturing millions of humanoid robots requires a truly staggering amount of capital. It requires a frictionless, ubiquitous way to capture and exchange the economic value generated by this automated labor.
So what does this all mean for the average person? How does this multi-trillion-dollar space and robotics ecosystem intersect with your daily life, and more importantly, your bank account? That brings us to the final piece of the architectural puzzle, X money.
X has been quietly laying the groundwork for a global financial network for the better part of 3 years, methodically acquiring money transmitter licenses state by state across the United States. And in March and April of 2026, they officially pulled the trigger and launched the limited external beta of X Money to a select group of users.
And from the leaks and the beta reviews we've analyzed, it is not just a simple digital wallet like PayPal or Venmo. The financial details from the internal beta are striking. When you are approved, you get this sleek, all-black metal debit card stamped directly with your X handle.
It feels very premium.
It does. They are aggressively undercutting traditional banks by offering a massive 6% annual percentage yield on cash balances stored in the app. The deposits are fully FDIC insured, up to $250,000 through a strategic partnership with Cross River Bank. And they have introduced an incredibly sticky feature called Smart Cash Tags, which allows users to trade stocks, index funds, and crypto directly from their timeline feed in real time without ever leaving the X app. You read a tweet about a company, you click the cash tag, and you execute a trade in milliseconds.
To understand the strategic intent behind X-Money, why a social media platform is offering 6% yields in metal debit cards, we have to look at the brilliant white paper by Rajesh Iyer titled The $10 Trillion Blueprint. Iyer argues that if you look at the entire Musk portfolio, it is no longer just a collection of successful tech companies. It has evolved into what he calls a planetary sensorium.
I love that phrase, planetary sensorium. Let's dig into what that actually means in practical data gathering terms.
It means that the combined, vertically integrated entity is capturing every conceivable form of economically valuable data across the entire spectrum of human and physical reality.
Covering all bases.
Think about it. Tesla's fleet of 9 million cars captures vision, spatial geometry, and physical motion. The Optimus robots capture proprioceptive and tactile data, the physical, localized feeling of interacting with objects in physics.
Okay.
The X platform captures real-time human language, political sentiment, emotion, and shifting cultural trends. Starlink captures global internet connectivity routing and data flow patterns. And Neuralink, which we haven't even had time to touch on today, is working on capturing raw, pre-linguistic human neural intent directly from the motor cortex.
It is the ultimate omniscient world model. If you want to train an artificial general intelligence to understand, predict, and ultimately interact with both the physical and the digital world, you need data.
Yeah.
And right now, no other entity on Earth, not Google, not the US government, not Apple, is capturing a wider, deeper, more multimodal spectrum of reality than this combined ecosystem.
Exactly. And X-Money is the final layer. It is the universal billing and transaction layer for this closed-loop ecosystem. Iyer draws a fascinating historical parallel in his white paper that I think perfectly contextualizes what we're seeing. He compares the projected trajectory of the Musk portfolio to the Dutch East India Company of the 1600s, the VOC.
Let's expand on that, because the VOC isn't just an old company. They effectively invented modern corporate capitalism.
Yeah.
They were the first true multinational mega corporation, and they were the first company to ever issue stock to the public.
And their power was absolute. Adjusted for inflation, the Dutch East India Company was worth roughly $8 trillion at its absolute peak. They achieved that unfathomable valuation by completely dominating two things: physical trade infrastructure and information asymmetry.
Okay, unpack the information asymmetry part.
They built massive fleets of armed merchant ships to control the spice trade routes from Asia to Europe. But more importantly, because they controlled the ships, they controlled the flow of information. A VOC merchant in Amsterdam knew about a drought in Indonesia months before anyone else, and they traded on that information asymmetry.
So how does Iyer map that 17th century spice trade monopoly to X-Money and Starlink?
Iyer argues that the Musk sensorium is doing the exact same thing in the 21st century, but instead of spices and wooden galleons, they are dealing in data network effects and optical lasers.
A digital monopoly.
By owning the underlying artificial intelligence, Grok, the global satellite communication infrastructure, Starlink, the physical labor force, Optimus and Cybercab, and now the financial transaction layer, X-Money, they are building an infrastructure that doesn't just compete within existing markets. It fundamentally dictates how those markets function.
Setting the rules of the game.
If you control the data, the labor, and the money, you achieve absolute information asymmetry. Iyer conservatively projects that as this ecosystem merges, it could easily eclipse $10 trillion in value, effectively becoming the largest sovereign enterprise in human history.
When you lay it all out like that, the supercomputer brain in Memphis, the robotic body in Texas, the optical nervous system in orbit, the lunar supply chain, and the financial cardiovascular system of X-Money, it really does feel like we're watching the real-time construction of an entirely new era of human civilization.
It's massive.
It is awe-inspiring, and frankly, from a regulatory and societal standpoint, it's a little intimidating. Which brings us to our outro, and a moment to summarize exactly what we've just unpacked over the last hour.
To briefly recap the sheer unprecedented scale of the Muskonomy we've mapped out today, you have XAI and the multi-gigawatt Colossus supercomputers providing the raw, centralized intelligence and the core reasoning engine. You have Tesla providing the physical embodiment of that AI through the Optimus humanoid robots and the Cybercab autonomous fleet, built using the parallel Unboxed method. You have SpaceX and Starlink providing the interplanetary logistics, the heavy lift Starship capacity, the lunar mass drivers, and the ultra-low latency global laser connectivity required to link the orbital brains to the terrestrial bodies.
And the financial piece.
And finally, you have X and X Money handling the human interface, the social discourse, and the financial transactions that monetize and lubricate the entire system.
It's a fully vertically integrated machine. And the key takeaway for you listening as you watch these headlines cross your feed tomorrow is this. While we will undoubtedly see delayed timelines, massive regulatory hurdles from the FCC and SEC, and explosive technical glitches along the way, the underlying engineering roadmap is not theoretical anymore. It's not just a white paper.
It's being built.
The gigafactories are actively being built. The starships are actively being caught out of the air. The Optimus robots are walking the factory floors. The structural shift from an earthbound human labor economy to an orbital automated economy is actively happening right now, piece by piece.
Which brings us back to that incredibly revealing conversation at Davos between Elon Musk and Larry Fink. Musk painted a picture of amazing abundance, a world where synthetic robots do all the heavy lifting, the cost of goods plummets, and poverty is theoretically eliminated. But Fink asked a critical, deeply philosophical question about human purpose and economic leverage in a world where autonomous robots vastly outnumber human beings.
And that is the provocative thought we want to leave you with today. If this vertically integrated planetary sensorium achieves everything it is set out to do, if it successfully captures unprecedented amounts of solar energy in space, and it completely owns both the physical labor layer through Optimus and the cognitive intelligence layer through Grok, who ultimately controls the definition and the distribution of that abundance?
That is the defining geopolitical and economic question of our time. If humanity's economic output relies entirely on a single, privately owned orchestra conductor managing the flow of data, labor, and capital, does that inherently lead to a post-scarcity utopia of human leisure and unbridled creativity?
Or is there a darker side?
Or, by consolidating the foundational infrastructure of intelligence, energy, and labor under one corporate umbrella, are we simply stepping into a completely new high-tech era of techno-feudalism?
It's a heavy question, and it's something for you to ponder long after this deep dive ends. Thank you so much for joining us on this exploration of the Muskonomy. Stay curious, keep questioning the headlines, and we'll catch you on the next deep dive.